Hello and welcome back. This is the notes for 8.7, and this is a section about solving inequalities. Now, an inequality is a statement when things are not equal. So this is when things are not equal, okay? Things are not equal. All right, and so let's go through the objectives here of what we want you to do. We want you to determine whether a given number is a solution of an inequality. We want you to be able to graph an inequality on a number line. We want you to be able to solve inequalities using the addition principle, using the multiplication principle, and using both of them put together, okay? So the first thing that I want to do is talk about an inequality, okay, up here. So let's kind of talk about what an inequality means, okay? And so let's talk about a couple, all right? Let's do a few of them here. And what I want to do is come up with something like this. The number 100, okay, is going to be greater than, say, 1, okay? Now, I can also write that as 1 is less than 100, okay? These mean the same thing. And what this means is that this one here, I like to just kind of think of the shark. A lot of people use the Pac-Man idea, but I like the idea of a shark, okay? And what I know is that the shark is going to eat the big number. So this number here is big. This number here is small, okay? And we can say the same thing, that this number over here is big and the number over here is small, okay? And you have to think about, the shark is eating the bigger number, all right? And so Pac-Man would also eat the bigger number, but the shark is eating the bigger number, all right? So that's kind of how I think about it. Now, you can also have this, a statement of inequality where, say, 1 is less than or equal to 100, okay? And, or say the same thing over here, that 100 is greater than or equal to 100, or I'm sorry, 1, okay? And these are all true statements, okay? Now, the one thing that I do want to say here is I'm going to put a disclaimer here, okay? So a disclaimer. And that is this. The disclaimer is that let's say I had like 1 is greater than or equal to 1, okay, which we already know, and this is true, okay, but what I also don't know is that 1 is greater than 1, okay, this is false, all right, so remember the line underneath that kind of tells me, whether we're going to also include that number or not. Okay, so let's kind of talk about what solutions of inequalities look like, all right, and how we get that. So let's think of something like this. Let's think of, say, something like x, some number x is greater than 1, okay? And what I would say is that, obviously this number here is big, okay, and this number here is small. So if I wanted to think about, the question is what values of x would make this statement true, okay? So if I said, well, what about, so my possible solutions would be this. Let me write this over here. So my solutions to this inequality could be a number of numbers, all right? There's a lot of numbers that are greater than 1, okay? So my solutions would be this, all right? Like x could equal 2, all right? So x could equal 2, all right? That's one of my solutions. The reason why is because 1 is less than 2. Okay, so I'm going to put that number here. I'm going to kind of plot that point. X could be a solution. Okay, what about x equals 3? Okay, that number is also larger than 1. So 1 is less than 3. Okay, that number works. And, let's think of, say, something like x equals 4. okay, 1 is less than 4. All right, that number would work. So what I'm noticing here is that all these numbers are possible solutions and make this inequality true. Okay, so what I would do is I could say, well, 5 is also there, 6 is also there, and even the numbers in between, like 2.5, like 3.5, all these numbers in between here. So any number that is larger than 1 is going to make this true. Now what we do is this, and what I want to think about is all these numbers, you know, and what I do is I shade where this solution set is. Now here's the thing. We don't include 1. Okay? So we don't include 1 in our answer set. Okay? Because we're strictly larger than 1. So what I want to do is so what that prompts me to tell me is that because I don't include 1, I use a parenthesis, okay, to show that. So my parenthesis here at 1 means that I don't include 1, but we shade everything else to the right of 1. Now what I want to do is something similar, and let's do the problem 1 is less than or equal to x. Okay, so what I know here is when I have x is greater than or equal to 1, that I include 1. Okay, so if we include 1, that means I want to use brackets. Okay, so I'm going to use brackets to show that. All right, so similar thing here. Okay, because we include 1, I'm going to put a bracket at 1. Okay, and all the numbers for x are going to be larger than 1, so my solution set is here. Okay, so what you end up having is you have a range of solutions that allow you to say, you know, what those values are. So like any number that's 1 or larger, you put in here is going to make it true. All right, now let's think of something else. All right, let's think of another problem, and let's do say that x, let's switch this up, x is less than, say, 1. Okay, so the numbers that would make this true would be numbers like x equals 0, okay, would make that true. 0 is less than 1. Another thing we could say is like x is equal to, say, -2. All right. And, you know, -2 is less than 1. That's true. So 0 would be there. -2 would be there. You know, let's think about x being equal to, say, -5. Okay, all these numbers that are smaller than 1. Okay, now because we don't include 1, okay, so I'm going to write here that we don't include 1. Don't include 1. That means that we're going to use parentheses. Okay, so now because I'm going to shade to the left of 1, okay, all these points are going to be shaded here. All right, what I want to do is put a parenthesis that faces this way, and that tells me that we don't include 1. Okay, and that's all we're doing. Okay, so these are solutions to those. Okay, now solving inequalities. All right, so let's talk about this. So we're going to have some crazy stuff going on here. Okay, so solving inequalities means that we are going to solve them the same way as equations. So the same way as equations. I did an update on my iPad. Oh my gosh. Did an update on my iPad, and this for some reason I just can't write very well with my stylus when they did the update. All right, so we're going to do this the same way as with equations, except, okay, okay, let me write, sorry guys, except, oh my gosh, except when, we multiply slash divide by a negative number. Okay. So let's think of some examples. All right, I apologize that this looks terrible. Okay. All right, so let's think of something here. Let's think of a true inequality. All right, and what I want to do is this. I want to say that like 1 is less than 10. Okay, 10 is larger than 1. All right, so now what I want to think about here is, you know, if I were to say like add like 3 to this, I would add 3 to both sides, okay? And what we're going to get is still a true statement. We're going to get 4 is less than 13, and this is true, okay? Let's say I take 1 is less than 10, okay? And let's say I subtracted, say, 1 from both sides. So subtract 1 from here, subtract 1 from here, and as a result, this is going to give me 0 is less than 9, okay? This is still a true statement, okay? Now, let's do this, all right? Let's take another inequality here. Let's take 2 is less than 10, okay? And let's multiply both sides by 2, okay? And what's going to happen is I'm still going to get a true statement. 4 is less than 20, okay? That's true, all right? Let's take 2 is less than 10, and let's say divide both sides by 2, okay? And what's going to happen is we're going to get, say, 1 is less than 5, okay? Both of these statements are true. So whatever I do to one side, I have to do to the other, just like you did when you solved equations, all right? However, you know, when you're doing this, when you're adding and subtracting numbers, it doesn't matter. But when you're multiplying and dividing, if I multiply by a positive number, I got true statements. So here's what's going to happen, all right? So let's think about this. So this is where we multiply slash divide by a negative. Okay, now let me think of a true statement here. All right, and let's think of something kind of outlandish, like negative 10 is less than, say, the number 2. Okay, and I'm going to do this twice. So negative 10 is less than 2. So now negative 10 being less than 2, let's say I multiply this by a negative 2 on both sides. And I multiply here by negative 2. All right, then what happens is that negative 2 times negative 10, all right, doing this here, this is going to give us a positive 20. All right. And that's going to be less than 2 times negative 2, which is going to give me negative 4. Now, what I know about this statement is that this is a false statement. All right? So what do I have to do to make this true? In order to make this true, I have to flip my inequality symbol, okay, to make it true. All right? So I had to flip my inequality symbol and reverse it. Inequality. Okay? Sorry, that looks just like crap. Okay, so anyway, let's do the same thing over here. So that was multiplying by a negative number. Let's do the same thing, but let's divide everything by negative 2 and divide this by negative 2. All right, and let's think about what happens. If I take negative 10 divided by negative 2, that's going to give me a value of positive 5. And this is going to be less than 2 divided by negative 2, which is going to be negative 1. Okay, this here is a false statement. All right? So in order to make it true, what I have to do is I have to flip my inequality symbol. Okay? So I had to flip this. Flip to make true. All right? So the rule of thumb is this. Okay? And what we can conclude is that, and I'm going to make a big star here, okay, if we divide, if we multiply, let's write that, multiply / divide by a negative, then we must flip the inequality symbol. We must flip the inequality symbol. Inequality symbol. Okay? And that's what we're doing. All right. So yeah, we've got a lot of, things going on here. Okay, I know that was kind of a long, drawn-out way to do that, but I wanted you guys to see that if I operate with these, then, what we can do is, we can do anything we want to do normally, except when we multiply and divide by a negative number. Okay, when that happens, we must flip the inequality symbol. All right, so we got a bunch of examples here. What we're going to do is do this, and then we're going to graph our inequality. All right. So when I do this, okay, I'm going to solve this just like I would any other equation. So I've got x plus 2 is greater than 8. I'm going to subtract 2 from both sides. All right. So subtract 2 here, subtract 2 here. And then as a result, I get that x is going to be greater than positive 6. Okay. And to graph this, all right, draw a number line. I usually plot a 0, and then I come over here and plot a 6. And the values for x are going to be larger than 6. Okay, we don't include 6. I'm going to come in here. I'm going to put a parenthesis, and we're going to shade to the right that x is greater than 6. All right, and that's all we're doing. Okay, so we're just going to solve them like we would, and then graph it. Okay, so let's do this one over here. This one involves quite a few more steps. First thing I want to do is combine my like terms. All right, so what I'm going to do is I want to get my x's together. So I've got 3x and 2x, and what I'm going to do is I'm going to subtract 2x from both sides. Okay, so I'm going to subtract a 2x from both sides. All right, as a result, 2x minus 2x goes to 0. I have to evaluate 3x minus 2x. 3 minus 2 is just 1x, which is just going to give me an x. Okay, so I've got an x, and then, let me do that in black. So x, okay, plus 1 is going to be less than or equal to negative 3. Okay, now what I want to do is I want to subtract 1 from both sides. So subtract 1, and as a result, we're going to get that x is going to be less than or equal to negative 4. Okay, now remember, I didn't multiply or divide by a negative, so I don't have to switch my inequality symbol. All right, but if I graph this, all right, let's graph it on a number line. Okay, I'm going to put a point where my 0 is, put a point where there's negative 4. Okay, and then because we're using x is less than or equal to, we want to use a bracket. Okay, and we're going to shade to the left because we're talking about values of x that are going to be smaller than negative 4. All right, so if we're smaller, it means we shade to the left. All right, and so here's what we've got. And we shade in that direction, and that's my graph. Okay, let's take a look at the next one. Over here, all we're doing, 8x is less than 64. I'm going to divide both sides by 8. Okay, divide this by 8. So the 8s are going to divide out, and we're going to get as a result is that x is going to be less than 8. All right, and so if I graph this on a number line, all right, I'm going to put a 0 here. I'm going to put 8 over here. my value for x is going to be smaller than 8. So we don't include 8, so I'm going to use a parenthesis, and we're going to shade to the left of 8. Okay? All right, let's move on. Let's do this next one. Now here we do divide by a negative. Okay? So negative 2 times y is less than 18. If I divide both sides by a negative 2, divide this by a negative 2, okay, these will divide out. And then we get that y is going to be greater. Now remember, I had to switch my inequality symbol. Okay, and it's going to be greater than negative 9. Okay, so as a result, draw our number line here. Okay, I've got 0. I've got negative 9. Okay, and y is strictly greater than 9, negative 9. So we're not going to include 9. We're going to use a parenthesis, and we're going to shade to the right. Okay, and that's it. That's all we're doing. Okay, so that's it for that part. Let's go down to the bottom over here. These are going to involve a little bit more steps to solve. Okay, so on this one, I've got 6 minus 5x is greater than 7. So the first thing I'm going to do is I'm going to subtract 6 from both sides. Okay, and then on the next step, I've got a negative 5x is going to be greater than 7 minus 6. 7 minus 6 is going to just give me 1. Okay, if I divide both sides by negative 5, now because I'm dividing by a negative, I'm going to have to switch my inequality symbol. So negative 5. Okay, and then as a result, that's going to give me that x is less than negative 1/5. Okay, and that's what I'm doing. All right, so then if I graph this, all right, let's find my 0. I'm going to find negative 1/5. I just know that's going to be to the left of my 0. Okay, and my values for x are going to be smaller than negative 1/5. Now, we're not going to include negative 1/5, so we're going to use a parenthesis, and we're going to shade to the left. And that's it. Okay. All right, on this next one, okay, I need to combine like terms. Now, there's a couple different ways of doing this. Now, what I notice is that, I could move my negative 5 over to the right side, or I could move 8y over to the left. Okay, now remember, when you do this, when you combine your like terms, you're going to have to, you're going to have to divide by that number. So if I move my 8 over, I'm going to subtract 8, and this number is going to be negative, meaning I'll have to switch my inequality symbol. So if you don't really like that step, kind of think about when you solve these, if I move this negative 5 over, that means I would add it to both sides, making this number positive. So I'm going to do that. Okay, and so I'm going to add 5y to both sides. I'm going to add 5y to here, okay? And then this is going to add to 0. I've got 17 is going to be greater than 13y, and then minus 9. Okay, 8y plus 5y gives me 13y. All right, the next thing I'm going to do is I'm going to add 9 to both sides. Okay. And so that's going to cancel out to 0. 17 plus 9 is going to give me 26. Is going to be greater than 13y. Okay. Now I'm just going to divide by 13 here. Okay. If I divide by 13, then I don't have to switch my inequality symbol because I'm dividing by a positive number. All right. So as a result, what's going to happen is 26 divided by 13 is going to give me 2. Okay. And then 13 divided by 13 goes away, so 2 is greater than y. All right, so, and this is a little bit different because I'm writing this a little bit, the y is on the right side. Okay, it doesn't matter what side it's on, but you have to think about when you graph this. All right, here's my 0, and here's 2. Okay, my values for y are going to be smaller than my values of 2. So for smaller, we're going to shade to the left. All right, so I'm going to come in here, and I'm going to put in a parenthesis, and I'm going to shade this way. Okay, and that's it. Okay, last one. Okay, this one's going to involve quite a bit of stuff. All right, here I've got to kind of get rid of my parentheses. This is going to require a lot of algebra. So let's do this. Let's go ahead and distribute our 3 first. Okay, distribute it there, distribute it to -2. Let's take -5 and multiply it by x, and then multiply it by 6. Okay, so my next step, I'm going to write 3 times x minus 2 times 3, which is going to give me 6. And then minus 1 is less than 2 minus 5x. And then -5 times 6 is going to give me -30. Okay. All right, so now what I want to do is I want to combine my like terms. So I've got -6 and -1. If I add those together, I'm going to get -7. Okay, and that's going to give me less. Okay, hold on. Let's drop the 3x down here. All right, so I've got 3x minus 7 is less than. Okay, now I've got 2 minus 30. That's going to give me -28. Okay, and then minus 5x. Now again, at this point, there's a number of ways of solving this, but I want to think about, all right, I don't want to have to switch my inequality symbol. So when I'm combining my x's, 3x and -5x, I want to move this negative number to the left side so that it stays positive. So I'm going to add 5x to both sides. All right, I'm going to add 5x. All right, so that's going to cancel out. My next step is going to be this. I'm going to have, what is that, 8x? So 8x and then minus 7 is going to be less than -28. Okay, now I'm going to go ahead and add 7 to both sides. So add 7, add 7. All right, so now I've got -28 plus 7. This is going to add to 0. So I've got 8x is going to be less than, -28 plus 7 is going to give me -21. Okay, now what I'm going to do is I'm going to divide everything by 8. Okay, divide this by 8. And those are going to cancel out, or divide to 0. I'm sorry, divide to 1. And we get that x is less than -21/8. Okay, now in order to graph this, all right, you don't have to be very specific, but let's just draw a number line. All right, and I'm going to put my 0 here, and then I'm going to put -21/8. All right, and my value for x is going to be smaller than -21/8. So when I come in here and draw that in, all right, I'm going to put a parenthesis here, and we're going to shade to the left. And that's what we're doing. Okay, so a lot of stuff's going on. Okay, it's kind of a long video. I apologize about that, but it is crucial that I do a bunch of problems and that you guys can see what I'm doing. So. You know, what you notice is that I try to avoid multiplying or dividing by a negative. Sometimes you can't avoid that. But, you know, all I'm doing is I'm solving these just like I would any other equation except for this one fact. And then we just have to make sure we're able to draw out our solution set. Okay, so I hope you enjoyed this video, and we'll see you soon. Thanks a lot. Bye.